Hello, this movie is for Learning Target 1, area of parallelograms, triangles, and other quadrilaterals. Area of a rectangle is the same as the area of a parallelogram. It is just base times height, and the thing to notice is that the base and the height are always going to be perpendicular. So when you have a parallelogram, the height would not be this, which is the slant height. The height is always going to be perpendicular to the base. So, base times height. The altitude is what's perpendicular, and you'll notice even with a triangle, you use the altitude as your height, base times height. Let's look at these. Pause the movie, try these, and then press play when you're ready. So in this first one, we're looking at the height as 4 and the base as 5. So the area is 4 inches times 5 inches, which gives us 20 inches squared. In the second one, the area is going to be a height of 3.5 because that's what's perpendicular to the 2. So we do 2 times 3.5 and we get 7 centimeters squared. Notice we don't use the slant height. With a triangle, it's the same thing. It's just going to be 1/2 base times height because a triangle is half of a parallelogram. So the base and the height of a triangle must also be perpendicular, just like that of a parallelogram. Let's look at this composite figure. If we get the area of the triangle, that's going to be 1/2 the base length, which is going to be 6, times the height, which is 8, which gives us 24, and the area of the square, which is going to be 6 times 6, or 6 squared, which is 36, and we add the two together to get 60 inches squared. Area is always units squared. A trapezoid is a little different of a formula. It's 1/2 height times the two bases added together. And in a trapezoid, you have one pair of parallel sides, and those two sides are called the bases, base 1 and base 2. Notice the height is still perpendicular to those two bases. So let's practice some trapezoids. So here we have a trapezoid where the bases are 205 and 511. The height is this 309. So the area is 1/2 the height, 309, times the two bases added together. And that will give us 110,622 miles squared. Down here, it's a little different. We do have a trapezoid, except we don't know the height. And because we don't know the height, we got to find it. And the only other thing that we've got is this 60-degree angle. So if I scooch the height over here, then what I have is a right triangle with a 60-degree angle. The next thing I could do is figure out what this length is. And I can get that length by doing 7 minus 5. So I know that that length right there is 2. So what I have is a 30, 60, 90 triangle where across from the 30 is 2. So what would be across from the 60? Well, what I know is the pattern for a 30, 60, 90 is A is across from the 30, A root 3 is across from the 60, and 2A is across from the 90. So for X, we're going to end up with 2 root 3. That's my height. So the area is 1/2 height times the two bases added together. And I'm going to type all that in. I will get an approximate because of the root 3. Or I could keep it as square root of 3, add these together, multiply, and then I get exactly 12 root 3. And then if you type it in with the root 3, you get an approximate. So I'm going to leave it as 12 root 3 because that's exact. This one's a little different. So we do still have a trapezoid. We have this guy as x. I'm going to scooch him down over here. Except I don't have a 30, 60, 90 or even a 45, 45, 90. What I have instead is a 50-degree angle. But I can tell this length right here. That length is going to be 12 because if I do 21 minus 9, that's what I get. And what I end up with this triangle is if this is 50 and I'm standing there, this is my adjacent side, this is my opposite side. If I do the tangent of 50, I will get x over 12. That allows me to solve for what x is, which is the height. So I'm just using trigonometry. So I do 12 times tangent of 50, and I get that x is approximately 14.301. So the area is 1/2 the height, which is about 14.301, times the two bases added together. And that tells me that the area is about 214.52 millimeters squared. Okay, that's trapezoid. Then we have the area of a rhombus or a kite, which is going to be 1/2 diagonal 1 times diagonal 2. Now this means the entire length of the diagonal, so be very careful here. We got to multiply the whole length. Here we have a kite, and so the area is 1/2. Diagonal 1 is 3 plus 3, which is 6. Diagonal 2 is 2 plus 5, which is 7. And then we multiply those and we get the area is 21 meters squared. What is the area of a kite with diagonals 12 and 9? Pause the movie, try it. Press play when you're finished. Yeah, it's just 1/2 12 times 9, which is 54 inches squared. Find the area given the rhombus. So we're going to need to know properties of a rhombus. And I know that because a rhombus is a parallelogram, because this is 2.5, this guy is 2.5. I also know that diagonals are perpendicular in a rhombus. That's where that right angle is coming from. I know that all sides are 6.5 because a rhombus has all four sides congruent. What I don't know is I don't know this value. So what I do know is that I can set up a right triangle. And I know that the hypotenuse opposite the 90-degree angle is 6.5. I know 2.5 is one of the legs, and I can solve for what x is. So simple Pythagorean theorem. And we solve this for x. So we get x is, let me type this in, 6.5 squared minus 2.5 squared. Oh, it's exact. Brilliant. So it's 6. So we get x is 6. And if that's 6, then this is 6. So when I get the area, I get 1/2 diagonal 1, which is 2.5 plus 2.5, 5. And then the other diagonal, 6 plus 6, which is 12. So the area is 30 feet squared. Okay, pause the movie. Try this on your own. Press play when you are finished. Right, it's a rhombus. So we know that this is a right angle. We know that this is also 6. We got to solve for x. So we end up Pythagorean theorem, x squared plus 6 squared equals 14 squared. I know that because the 14 is opposite the 90-degree angle. And so I get x squared equals, 14 squared minus 6 squared gives you 160. X is approximately, let's keep it approximate, 12.649. So if that's 12.649, this is 12.649. And so the area of this guy is 1/2 diagonal 1, which is 6 plus 6, times diagonal 2, which if I add those two, I get about 25.298. And that gives me an area that's approximately 151.79 meters squared. And that's all for this movie. Thanks for watching.